So far, we have covered a lot about what? Not about the periodic, I'm sorry, not about the periodic table itself, but about the actual what? Boxes themselves. Now we really understand, because we've been at it for like 3 days now, we understand what the box has, what each symbol in it, or what each part of the box means, and so on and so forth. And next week, we will have a quiz, at least on the first part that we covered. So today we are going to do what? We are going to look not just at the specific boxes, but we're doing the entire what? Periodic table. Okay, so let's just understand, everyone, let's just understand why it's called periodic table. Obviously, first it's called a table because it looks like a table. What's a table? A table is basically when you have things lined up like this and like this as well. So anything that looks like this, whether it's full or not, you might say that's not a full table because, for example, all this whole part is missing, or this whole part is missing, or this part is missing. That is fine. That's just a part of the table that's not being used. Okay, and it's called periodic. That's actually the key word here, everyone. Periodic. It's called periodic because that means that elements that are near each other have what? Have periodic or similar behaviors. They're not the same, but they do kind of like act the same way. Okay, I'll explain what that means very soon. So let's start with the first slide. Here it is. So everyone, let's just quickly define what we have here. So the first thing is we're going to talk about elements. What's an element? An element is basically what? An element is a pure substance. So again, let's remember, an element is a pure substance, meaning an element is an object, an object made up of one single kind of an element here. Okay, so if I give you like a pure rock of carbon, the only thing in it is just carbon. That's an element. Okay. If I give you a chunk of, I don't know, a chunk of, well, I can't give you hydrogen, it's a gas, a chunk of lithium, you know, that the thing that goes into batteries, that's a what? That's an element of lithium, and so on. Okay, Ahmed? So all elements have what? Characteristic physical properties. Okay, we need to understand something. Does anyone know what does characteristic mean? Come on, in English, because again, these words must mean something. Yes, Turk? Yes, characteristic means describing the character or describing the thing. So, for example, you can say something like, let's say someone comes into the school and they're looking for me. They're going to ask you, what's a characteristic of Mr. Ramadan? You could say, oh, he wears a hoodie. He's the guy in the hoodie. I think I'm the only teacher in the hoodie. Okay, or he's the teacher with the long hair, but I'm not the only one. Because what's up? Where a few of us do. Or I'm the teacher with long hair, but I'm not the only one because Mr. Williams has longer hair than I do. Okay, so characteristic means what? Something that tells you a very specific one thing, something that defines you only. Okay, what's a physical property? Can anyone tell me what's a physical property? If I ask you right now, can you tell me a physical property of this eraser? Basically, I'm asking you to describe this eraser. Come on, give me a physical property or a couple of physical properties. Come on, people. It's what? It's half. Yeah, okay. But like if you want to describe its appearance, what would you say? Give me just, it's white. It's grayish white. So perfect. That's a physical property. What else? Is this eraser a solid, a liquid, or a gas? No, like liquid means like water. This is a solid. What other physical properties could it have? Do you think it's heavy or light? Light. So you're describing the physical. You did not mix it with anything else. Okay. So a physical property is something that describes the thing just by looking at it, not mixing it with something else. Okay. So all elements have what? Characteristic physical properties, which means they have physical properties, almost what? Unique, or almost just them. They have it. Unique to that substance means only to them, and it's a way to help identify that substance. By the way, is it important to be able to identify substances? Of course. When you go, okay, how many people here do blood work? Like you go and you do blood work. Do you know what blood work is? Blood work is basically when you're sick or you're feeling sick, and you go to Life Labs or a clinic, and they basically what? Inject you. No, actually, they don't inject you. My bad. They just put the needle in, and what do? They take out what? They draw or they withdraw or they suck out blood of you. They put it in a little vial. Maybe they don't do much. Maybe 10 milliliters. No, not 10. Yeah, about 20, 30 milliliters. Depends how much they need. and then they send it to the lab, and then they what? They are trying to see what's inside of your blood. Whether good or bad, they still need to deal with see what's inside of the blood. And through chemistry, they can identify what's inside of your blood. Do you have more cholesterol, less cholesterol, for example? Are you missing some protein? Do you have a lot of iron? How is your hemoglobin level? I don't know, do you have a virus? Do you have some bacteria in your blood? A billion things. Blood work now is the most important thing you can do to actually know if you need medicine or not. Okay? So, what are examples of what? Everyone? What are examples of physical property? Okay, density. Density. No, hold on. But what's density? What is density? Everyone. Density, listen up. I'll explain what density is. Density is important. Density is not how heavy something is, but how heavy, everyone, how heavy compared to how small. How heavy compared to how small. So for example, this eraser right here. If I weigh it, we have a scale right here. If I weigh it, how many grams do you think it might weigh? I don't think this makes it to 200 grams. By the way, 200 grams is 200 grams is 1/4 of a pound. Sorry, my bad. 1/2 of a pound. Does this weigh half a pound? No. Okay, so it's much less than 200 grams. I know, my guess is 30, 40 grams, something like that. 30, 40 grams. That 30, 40 grams is the M. Does anyone know what M means? It's something like the word weight, but it's another word. It tells you something, how heavy something is. Starts with M. Come on. If you want to know how heavy someone is, you can ask them, how much is your weight? Or how much is your, thank you, mass. So M is always mass. What is V? By the way, sometimes they don't write small v, sometimes it's capital V. Huh? Volume. What's volume? How big something is. How big? Not how heavy. How big. So you never know volume by this. Everyone, look. You never, guys, you never know volume by going like this. That's not how you measure volume. That's how you measure what? Mass or weight, because it feels heavy or feels light. Volume is what? How big something else. Can you tell me how big this is? Well, you're going to... No. Okay. Grams is not heavy. Sorry, grams is not big. Grams is heavy. How do you report how big something is? Do you know how we say it? If I ask you right now, how big is this classroom? Yeah, but you have to give me a number. And you have to give me a unit. Do you know how we report how big something is? Does anyone here know? Okay, how many people here know how you describe how big a gas tank in a car is? If you're filling your car with gas, you need to know how big the tank is inside of the car. How would you know? Does anyone know how you report how big a gas tank is? Huh? Thank you. So that's one way. One way you can say what? Liters or milliliters if it's a small thing, like a cup. Like that. That bottle is not big in liters. How much? Is it written on it? That's not 300. That's actually 591. Standard size for water bottles, 591. Okay. Does anyone know another unit? Come on. For how big something is, like the gas tank. Has anyone seen this unit before? If anyone here drives a motorcycle or knows someone who drives a motorcycle and you ask them how big is your motorcycle, you're asking them how big is the gas tank on the motorcycle. Yes, cc, but what does it stand for? That's the thing. They say, oh, my motorcycle is 300 cc, 400 cc. The big ones, the ones that like police use, for example, could be like 700 cc's and so on. But what does cc stand for? Cc stands for not cylinder. Cylinder. Good. Who says cylinder? Cylinder does not describe how big the gas tank is. Cylinder describes how strong the engine is. 6-cylinder, 8-cylinder for a car and so on. This stands for, everyone, cubic. What's the second word? Centimeter. Cubic centimeter. Do you know what a cubic centimeter is? Everyone? It's a little cube made up of what? 1 centimeter, 1 centimeter, 1 centimeter. Just like this. Imagine if you make, obviously it's got to be a small cube. 1 centimeter this way. 1 centimeter this way. And 1 centimeter this way. That's how big 1 cubic centimeter is. If you have a gas tank 600 cubic centimeters, that means your gas tank is as big as 600 of these collected together. 600 of these collected together. So it could be, for example, maybe from here to here, and then into the board, like that way, maybe like this way to this way, and then maybe a little bit this way. So imagine 600 centimeters could be roughly this box. Hold on, it has to be, yeah, kind of. Yeah, it has to be perfectly lined up. Yeah. Yeah. Do you see what I mean? That could fit 600 of those small ones, more or less. I mean, but you get the idea, okay? So that's one way. Yes. What? Yeah, go ahead quickly. Okay. So, but how big is this one? Is this a lot of cubic centimeters or just a few? Come on. I showed you how big 1 cubic centimeter was. How many of those small ones could fit into here? 3 or 4? Yeah, I would say 3 or 4. Okay. So what's the size of this, or what's the volume? 4 cubic centimeters. 4 cubic centimeters. If you want to know how dense this is, like how much density, you have to divide. Do you remember what we said the mass of it was? Come on. No. The mass. How heavy? Do you remember how heavy? 35, 40 grams. And how much is the volume? What did we say? How many? 4 what? 4 small cubic centimeters. You divide 30, or so I think we said 40. You divide 40 by 4, 40 by 4, and you will get the what? You will get the density. Okay, here's my question to you, everyone. Yes. Yes. So everyone, question for you, guys. What if this, for some reason, I leave it here, I come back tomorrow, okay? It looks the same, like same size, but then I lift it up and it feels a lot heavier. It looks the same, but it feels a lot heavier. Not just feels, it really is heavier. What changed? Did the volume change or did the mass change? Again, it looks the same, so I pick it up thinking that, what changed in it? No, it looks the same. It looks the same. It still looks the same size. So it's the same what? It's the same amount of cubic what? Or as Ahmed said, it's the same amount of liters, like the same size. But I come and pick it up and it's heavy. So what changed about it? Come on, what does M stands for? I need everyone to know this. Mass. So the mass got heavier, but the volume stayed the what? Same. What does that mean? Is it less dense or more dense? Think about it. There is more mass, there is more electrons and protons and neutrons now. I don't know how that happened. I'm just saying if it happened. That means there's more mass in the same volume. Okay, here's a question. What if I come back the next day, everyone? What if I come back the next day and I left it? Oh, and it feels so light. Now what happened? It looks the same though. So what's still the same? The volume is still the same. It's still how many? 4 cubic centimeters, because it's so small. But what happened to the mass if it was very easy to grab? Did it become heavy or light? If I just go like this. No. The volume is the same. The size is the same. But when I lifted it, it was very easy to lift. So did it become heavier or lighter? Lighter. So what does that mean? Okay. Did it become more dense or less dense? Less dense. Okay. I'll give you an example, everyone. How many students do we have here? 23. We should have 23. Does everyone feel comfortable? Yes. Like, is everyone sitting, do you have good space between you? Yeah. Imagine if the what? If the walls of the classroom move inside. And they move inside. And they move inside and they move. Imagine if this wall moves from here to here. And this wall moves to here, from here to here. And that, like, imagine if each wall comes in, I don't know, 3 or 4 meters in. Are we going to be more spaced out or more cramped up? Okay. So what does that mean? Is it going to feel that we are further apart or closer together? We actually have to move in what? Closer together. I can't move in this space anymore because the wall now is here, right? So I have to be here, right? You can't be here because it's going to move in a little bit, so you have to get closer. What does that mean? Do we have more space or less space between each other? Less space. So are we going to feel less density or more density? We have less size, but the same number of people. So are we less dense or more dense? More dense. Density means how pressured are you? If you are more pressured, you have what? You have what? High what? High density. If you are less pressured, you have what? You have low density. How could you fix that problem though? If the class becomes smaller, I have to what? I have to remove some people, right? For example, if the class loses half its size, I can't have 23 people here. To keep the same feeling, yeah, half of the people have to what? If we lose half the size, then half the people technically should what? Should move out to feel the same what? Spacing with the people who remain in the classroom. Okay? So what does density mean? Density means if you have high density, you're what? You're what? You're shrinking, exactly, or you have more stuff in what? In a smaller size. If you have less density, that means what? You're more spread out. Okay? So that again, does it make sense what density is now? Density just means, are you feeling more pressured or less pressured? More pressured, higher density. Less pressured, lower density. What else is important in characteristic? What's this word? Come on, people, phones away. Trying to explain words, and if you're not listening, come on, you're smart. If you're not listening, nothing is sinking in. What's freezing? How do you freeze something? So what's happening when you put something in the freezer? I need more than that. Yes, that gets really cold. So what's going down? What's very, very low in the freezer? Or temperature. So what is freezing point? Freezing point is when you have a liquid. And you keep looking at it, but doing what with the temperature? As Sahar said, getting what? By the way, okay, is this solid or still liquid? Okay, if I put it in the fridge, is it ever going to become, not in the freezer, in the fridge, is it ever going to become solid? No, it's got to become what though? It's got to become, no, it's going to stay solid, but what's going to happen to its temperature? It's got to become, no, I didn't put it in the freezer. I just put it in the fridge. Just got to become cold. Like the juice I give you sometimes. But what if I do it to take it in the freezer? Then it could what? It could freeze, okay? Come on. Every liquid has a freezing temperature. If you hit it, it will what? It will freeze. Every liquid has a freezing temperature. Some liquids don't have what? Don't have the same freezing temperature as what? As other liquids. Some liquids freeze at minus 15 degrees. Some minus 4. Nitrogen. By the way, nitrogen naturally is a liquid or a gas? I'm breathing it right now. Right now in air, there's what? Gas nitrogen or nitrogen gas. Guess what? We can actually make what? Liquid nitrogen. But we can't make it in the classroom. You know what is needed for nitrogen to freeze? Oh, yeah, sure. One second. When someone comes back. It needs to go down to minus 40 degrees. By the way, how cold does it get in London? Do you know? I mean, come on, you've been living here. How many people have lived in London for like over 10 years? Okay, we've got so many bad winters, but how cold does it get on the coldest day? Yeah, I don't think it ever, with the wind chill, like when the wind is blowing in your face, I don't think it could feel any colder than what? Minus 30 degrees. Guess what? That's so cold. Guess what? Liquid nitrogen will still stay liquid. Sorry, nitrogen gas will stay a gas in that temperature. But if the temperature drops to minus 40 below, then if you have like if this was full of nitrogen gas, you will start seeing it what? Become a liquid. But you need to hit what kind of temperature? How much was it? Negative 40 degrees. You really need to make it super cold that the gas will become what? Will become a liquid. Okay, what is melting point? How do you melt something? Yeah, can I melt this? Yeah, I can. I need a stove or an oven, and I put it inside of it, and what happens to the temperature? Instead of going down, it goes what? Go. But what is this? Is this a gas, liquid, or a solid? This is a solid. Okay, this is solid. You melt solids. Every solid has a what? Has a certain temperature. You will put it in, and you keep raising temperature. Once you see it start melting, for plastic, that's the what? That's the melting point of plastic, for example, or of your bone, or of your skin, and so on. How about boiling point? What do you boil? Water. And water already is a what? What state is water in? Gas, it's liquid. So you boil only liquids. Again, every liquid has a what? Yeah. Does anyone know what's the boiling temperature of water? When does water only boil? When you reach, if you have a thermometer, and okay, everyone, you have a kettle and you're heating up water, and you put a thermometer in, and you keep heating up. You start seeing the temperature what? But you're still seeing that it's liquid. When does it actually start boiling and becoming gas? Does anyone know what's the boiling temperature of water? 100 degrees. Water freezes at 0 and boils at 100. So between 0 and 100, it's liquid. Between 0 and 100, it's liquid. 0 and below, it's ice. 100 and above, it's gas. That's how it goes all the time. But by the way, you need to know something though. Freezing, melting, and boiling, yeah, we kind of know them, but they also depend on something else. Most importantly, what? Who can read this word? Pressure, air pressure. What's air pressure? How much air pressure is inside of you? By the way, what do you think happens to air pressure as you climb up a mountain? Yeah, it becomes what? Very hard to breathe, because the air pressure is what? Lower. You can actually suffocate. That's why you need oxygen tanks when you go up like Mount Everest and so on. Okay? Because the oxygen there is getting what? Less and less and less and less. Do you know that sometimes soccer players, if they play in countries very, very, very high up, they actually can't play anymore? Or they can't play as well? Do you know where Chile is? Does anyone know where Chile is? Chile is a country in South America. It's actually the thinnest country in the world. If you look at South America, the map, Chile is the one just on the edge. Okay, it's very high above sea level. Yeah, they took players from normal countries. They're athletes, like they're training every day. They have good lung capacity and everything. They put them there. The players were barely able to breathe. But the Chilean players had no problems, because they were already used to what? Muscles and oxygen at low. They were okay. The other ones were used to what? Low. So they were used to a lot of oxygen. They put them in a low oxygen environment, and they were barely even to, like, they would run, but they couldn't last the whole 120 minutes of the match, just because they're not used to it. Okay? So it's very interesting. So if you actually take water, everyone, and you actually try to boil it on top of Mount Everest, guess what? It doesn't boil at 100. It boils less. Yeah. So you can actually boil it. Because the air pressure affects it. Here, there's so much air pressure, you need a high temperature. If you go up to Mount Everest, you can actually make tea at 50 degrees Celsius. But you need to go up in Mount Everest. Sure. But that's my point. Okay? All right. So this is the periodic table. I don't think we have anything in this one. Okay. Come on. Let's do this. So, everyone, what did we say? Come on. Every table is made up of how many things? Come on. How many? Two things. Rows, the horizontal ones, and columns. Well, in the periodic table, everyone, they don't call them rows and columns. They call them something else. The columns are called what? Come on. They're called what? Groups. They don't call them columns. They look like columns, but we have to call them a chemical name. They're called groups, yes. So what do we call? Come on. What do you call the vertical columns? You call them what? They also call them something else. You can call them families, because they do what? They do have a lot of what? Similar behaviors together. Okay. Elements or boxes in the same family have similar what? What's this word? Properties. Like, you know, they have similar features. They have similar things about each other, because they have the same what? Who remembers this word? Come on, let's valence. Again, this is an E, but you actually kind of say it as an A. Valence. Let's say it together. Valence. Does anyone remember what were valence electrons? I'll give you a hint. When we sketched a lot of Bohr Rutherford diagrams yesterday. Like, well, not exactly like this, but basically we sketched, remember? What did we sketch? We sketched the center circle, and then we sketched the first one, the second one, the third one. How would you know where the valence electrons are? Come on. Abdullah? Yeah, let's say you did all the circles. How would you know where the valence electrons are? Last circle. You just count how many what? Yeah. See, this is an easy course. You just have to pay attention. You just count what? You just count how many what? Electrons in the last circle, and these become your what? These are the ones that you can exchange with other atoms to what? Elements to make a chemical reaction. Nice. Apparently, they number the groups. They number the groups to determine or to tell you the what? No, not hashtag. Number. So the group number is the number of what? Valence electrons. That's why if you understand how to read the periodic table, you can really know a lot by just what? By just looking at it. If someone tells you, hey, this element is in group number, for example, 5. What am I also telling you? If that element is in group number 5, that element has how many valence electrons, Abdullah? 5. The group number is the same number of the what? Of the electrons on the outside circle. Right there, without even sketching the Bohr Rutherford. It's already, everyone, this is why they spent years, 250 years ago, building this. Because they had to make sure that we are not going to put an element where it could be, tell me what, wrong information. If I'm going to put an element in a spot, it has to be the perfect spot to what? To really tell me that it belongs to the correct family, it has the same properties as a lot of the things above and below it, and that the group number it's placed in, group 1, group 2, group 3, group 4, and so on, gives me also the same number of electrons. Otherwise, if you make a mistake in this periodic table, you would do the wrong reaction, and it could lead to an explosion. You could make a certain, for example, chemical that could be the wrong kind of medicine, and it would kill people. They had to spend years putting them. It's a puzzle piece. That's the most important puzzle in the history of humanity. Okay? All right. How about the other ones? So the vertical ones are called what? 2 names. Groups or families. The horizontal ones, thank you, Ahmed. The horizontal ones, again, what are they called in general? Who can read this word? Row. A row is just something this way. Column, row. But they have another name. They call them what? They call them periods. Okay? So we have what? We have groups. Everyone look at me. We have groups or families. And we have what? We have what? Periods. Groups or families and periods. These are the only names you need to know about. They look this way or that way. Okay? So what does the period number tell you? Look, everyone, again, just a quick reminder. The group number told you the number of what? The period number, like where is it this way? Is it first row? Is it second row? Is it third, fourth, fifth, sixth, and so on? Tells you the what? Represents the number of what? Electron what? Orbit. It just tells you how many circles there are. It doesn't tell you, everyone, again, remember, one of them tells you what? How many electrons are on the last circle. This one doesn't tell you how many electrons on the last circle. It tells you what? It tells you how many circles in general you have. How many circles? So both of them are important. One of them tells you just how many circles you need to make the diagram. The other one just tells you if you make it to the last circle, how many dots do you need to put, or how many electrons. Okay? So these are the most 2 important things. Now we're gonna do this, everyone. I believe we are. Yeah. Now we're gonna fill all of these, because every part of the periodic table has a name and trend, like properties or behavior to it. Okay. Are we good so far? All right. Not much to copy. Okay. So let's talk about the first one, everyone. Again, nothing here. Okay. Can you tell me which group is highlighted here? Do you see which one has a box around it? Yeah, exactly. Those red ones. Interesting. Did they include this with them? Yeah. That is hydrogen. That is so special. It's almost its own thing. All right. By the way, it's interesting. Do you see how many color groups there are? Can you count? Okay, how many people say there are 6 color groups? You know what? Include everything. E, 7. Okay, let's see. What color is this? So we have a red group. No, what color in all of these? Red. What color is this? Orange. Okay, so 2 colors so far. All of these. These have not been discovered, so they're just put blank for now. What are these colors? So 3 colors so far. How about this one? And all of these. Blue, so 4 colors. How about these? Greens, 5 colors. And these? Yeah, both of these are what? But are they the same exact purple? No, this is kind of light purple, and this is darker purple. So we actually have what? 8. 1, I think. 1, 2, 3 with these. 4, 5. Oh, sorry, 7, right? 1, 2, 3, 4, 5, 6, 7. Yes, 7 groups. Or sorry, not 7 groups, 7 colors. Okay. So I believe. Hold on. Don't copy anything yet. Wait 1 second. Okay, everyone. What you're gonna cover now. So all of these, all of this, you are gonna write it on the bubble on the left because you have this, right? Remember? Hold on 1 second. I want to make sure that you know exactly where to copy so you don't mess up your notes. Give me 1 second. Day 4. No, day 4. There we go. So we will, everyone. Okay, right here. We are going to start here because this one is placed next to which group? Those ones. Okay, so I want you to write what? In the bubble, you write whatever is in the bubble in the slideshow, but above the bubble, you write alkali metals right here. So let's start. So there we go. Go ahead. So on top of the bubble, yes. Sure. Yeah, so yes, so 1 second. So everyone, all of this, I hope you have enough space. Try to write small, I apologize. I just want to fit it on the same paper. All of this goes in the bubble, and what's on top of the bubble? Yeah, whatever is on top of the bubble is on top of the bubble. I've heard alkali, but I believe it's alkali. Alkali metals. Hold on 1 second. Let me just show you. Oh, 1 second. Yes, so those are alkali metals. Lithium, sodium, potassium, rubidium, francium. Okay, so go ahead. So, yes, I can zoom in for sure. So what properties what properties do alkali metals have? Well, they're shiny. What does shiny mean? Come on. Shines, like when you clean your shoe, especially if it's leather, it's shiny, it's super clean. Okay, if it reflects light, it reflects light. Shiny. Solid. Yeah, everyone. None of them is liquid. Well, unless you what? How can you make a solid a liquid? Come on, how can you make a solid a liquid? How can you make a solid? Yeah. Put it on fire, or basically what? Melt it. But in room temperature, like if I give you if I give you some sodium right now or lithium, yeah, I can't put it here. I have to give it to you in a box or in my hand. It's solid. It's like powder. Yes, sure. Okay. So they are shiny. They are solid. It's okay. You can go. Shiny, solid, very soft. What does that mean? Yeah. If you feel them, it doesn't feel rough. It actually has a very soft surface. Again, let's just quickly look at the picture. 1 second. Yeah. Okay. So they can what? They don't have a lot of roughness. Okay. What else? What does silvery mean? Yeah, but what does silvery mean? They kind of look like silver. By the way, what's silver color? If you have a silver colored car, it kind of looks what? Huh? Gray. Okay, what else? Oh, sorry. Oh, that's my bad.